And welcome again once for one more session on mechanics, where we will do some problems on Newton's laws and conservation of energy. So let's look at the first problem. We have rain falling vertically at a rides bicycle with a speed of 12 meters per second in east to west direction. What is the direction in which she should hold her umbrella? So let's look at the solution. So first we talk about the velocity vector of the rain and the woman. So this is the velocity vector of the woman and this is the velocity vector of the rain. So the resultant vector is the direction. So this is the resultant vector of the rain as seen by the woman. So the angle at which the woman should hold the umbrella is tan theta is v over the velocity of the woman. So we straight away put the numbers, so 12 meter per second and 12 meter per second. So we get tan theta is equal to 1. So we get since tan of 45 degrees is 1, we get angle theta as 45 degrees. So the umbrella should point in the opposite direction to that of the rain, and so it must point towards the west. So that is the angle at which the woman should hold the umbrella. Let's look at the next problem. We have a body which is initially at rest and it undergoes one-dimensional motion with constant acceleration. The power delivered to it in time t is, so we need to calculate the power, and the options we have is t square, square root of t, then t, and t raised to 3 by 2. So let's look at the solution. So if F is the force acting on the body and V is the velocity, then the power delivered to the body is product of the force and the velocity. Now the body is initially at rest, so we can straight away use the kinematic equation V is equal to U plus AT, where U, the initial velocity, is 0. So we straight away write velocity after time t is the product of acceleration times t. So this gives us the velocity of the body. So we now write down the expression for the power, since the force is mass times acceleration and velocity is acceleration times the time at which we are looking at the power. So we get this product as mass times acceleration square times t. So now the power delivered is proportional to the time. So the correct option is C. Let us look at the next problem. At a metro station, a girl walks up a stationary escalator in 20 seconds. If she stands on the escalator, then the escalator takes her up in 30 seconds. Now we need to find out the time taken by her to walk up the moving escalator is, and there are different options. So let's try to do this problem. And we start doing this problem by considering length of the escalator. So let L, capital L, be the length in meters. So when the girl walks the escalator, so we can find out her speed, which is L by 20, because she takes 20 seconds to walk the escalator. So this is the speed of the girl. Then the speed of the moving escalator is L by 30 seconds. So now when the girl walks on the escalator, we just add up these two speed, because now the girl is walking on the escalator and also the escalator is moving. So we add these two speeds, so L by 20 plus L by 30, which we get as 5L by 60. So we need to find out the time taken by the girl to walk the moving escalator. So we just divide this L, because she will eventually walk or move a distance of L. So L by V, so which gives us L by, now we have this fraction in the denominator, which gives us a time as 12 seconds. So that's the correct answer for this problem. Let's move to the next problem. We have a horse which is pulling a cart, and the force exerted that helps the horse to move forward is the force exerted by, and there are different options: the cart on the horse, the second option is the ground on the horse. So there are different forces. So the cart is exerting forces on the horse, or the force exerted by ground on the horse. The third option is the force exerted by the ground on the cart, and the fourth option is the force exerted by the horse on the ground. Now this problem is about the action reaction pair. So the action reaction pair between the horse and the ground is the force exerted by the horse on the ground and the force exerted by the ground on the horse. So this is what this action reaction pair is. Now the action reaction pair between the horse and the cart is related with the motion of the cart. So the force that moves the horse forward is the force exerted by the ground on the horse. Okay, so this is the correct option, the option B. Let's look at the problem. A block of mass m is placed on smooth inclined plane of inclination theta with the horizontal. The force exerted by the plane on the block has a magnitude of, so we need to find out the force exerted by the plane on the block is, and we have different options. So let's try to find out the solution. So here is the free body diagram. Here is the block which is placed on this plane which is making an angle theta. So this is the force due to gravity mg, and since this is angle theta, from the trigonometry we can figure out that this angle is also theta. So now we get this component as mg cos theta, and the force which is parallel to the plane is mg sin theta. Now we can see that the normal force, which is this arrow, is the force exerted by the plane on the block. That is what this n is, and we can see that since the block is stationary, essentially these two forces are identical in magnitude, and we can see that now this component is equal to the normal force. So this normal force is equal to mg cos theta. So the correct option is mg cos theta.